My research focuses on understanding of the spatial temporal structure of tap water sources and overall functioning of the pipework network through an urban system landscape of the Dallas-Fort Worth Metroplex and another study area in Gaborone, Botswana in Africa. In the context of this rapid urban growth and inter-annual climate variability, the specific objectives of my study are to determine the sources and the process controlling the isotopic composition of tap water in urban systems, and to assess the potential of tap water isotopes as a tracer for urban water management and conservation, as well as to develop a predictive model for tap water isotopes based on key environmental factors and water management practices. In the last decades, the urban population has seemed to be rapidly increasing, and projections indicate that by 2030, approximately 70% of the world's population will be living in the cities. Therefore, it's really important and crucial to understand how water distribution happens in an urban system, to largely depend, because the population depends largely on water resource across mountain ranges, extensive groundwater or surface water interactions, and water transfer from distinct river basins. However, after decades of hydrological studies concentrated in the streams, the spatial and temporal interactions between water sources and urban water supply systems remain one of the more poorly understood water cycle processes, hence the need for this study. In Gaborone, we collected samples on 2 different seasons, as well as here in the Dallas-Fort Worth Metroplex. So we are in a way trying to understand how tap water, how we can use isotopic analysis in tap water to understand regional hydrology for different climates, and how climate and seasons or temperature, they really affect the isotopic analysis. Here in my results for my preliminary studies so far that I've done for one hydrological year. And then the summary and in conclusion is that the cluster analysis revealed the prevalence of distinct water sources distributed across Gaborone, agreement with the structure of the water supply for water sources, two main dams in Gaborone, be the Gaborone Dam and the Boka Dam, and the other one from the north part of the country, as well as the groundwater fields. And there's also a water blending that was seen from the results. In Arlington, 2 water sources were also identified, with 2 main groups for the 2 seasons, 2 clusters. So we used the cluster analysis to arrive to the 2 water sources. And then the isotopic time series, they also indicate that water blending between sources and the arrival of 1,000-year rainfall event signal to the tap water system was seen 7 days after a large flooding event was in Arlington, which is in last year, August. Our results, they also show the high sensitivity of water isotopes to detect water sample engineering practices, and pose a new paradigm for drinking water quality monitoring and during extreme flooding events. Thank you.